Go look at a picture of a star. Or I guess I could show you one. Now, have you observed anything strange? That photo doesn't have any green stars. Why? It's a captivating cosmic riddle that introduces us to the fascinating fields of the electromagnetic spectrum. Let's first examine what the electromagnetic spectrum is to better comprehend why there aren't any green stars. With tracks ranging from radio waves to gamma rays, it's quite equivalent to the ultimate cosmic soundtrack. Visible light, with which we're all quite familiar with, lies just in the midst of the sublime spectrum. Imagine the spectrum as a rainbow of colors, with our elusive green light snuggling in between yellow and blue. The peak color of a star, or the wavelength at which it emits the most light, is frequently visible to us when we observe it. It stands to reason that a star would appear green if it emitted green light primarily. Not quite though, light is not emitted at just one wavelength. A star that emits green light will also emit wavelengths that are on either side of green, with some falling in the blue region and some in the red. The star's overall appearance is created by the combination of these extra hues. This is the exciting part. White light is created by combining the three fundamental colors of light, which are red, blue, and green. We call this process additive color mixing. Therefore, the presence of red and blue wavelengths causes the overall color of a star to merge into white, even if the star's peak emission is in the green spectrum. Stars are not the only objects with this color mixing. The idea underlying the colors we encounter on a daily basis is the same. Red, green, and blue pixels, for example, are used to form a spectrum of colors on the screen you're probably watching this video on. You may be asking yourself, why aren't white stars visible all the time? The dispersion of a star's light across the whole spectrum holds the key to the solution. Certain stars may look mostly warm or cold, with a peak in the red or blue areas. In a nutshell, light interacts with the electromagnetic spectrum in a complex way that accounts for the lack of green stars. A star may peak in emission in the green, but because stars radiate light at different wavelengths, its hues blend together and make them appear white to the human eye.